The age of computers. First there was computer-aided design, then came computer-aided manufacturing, followed by computer-aided engineering. Now it's time for computer-aided inspection. Our world is becoming more complex every day. Designs of manufactured goods in the aerospace, automotive, and plastic industries have evolved into more complex, unique shapes. And these shapes need to be manufactured to precise tolerances. As an aerospace engineer once stated, if you are traveling at Mach 4 in an aircraft, the shape of the aircraft had better be exactly matched to the flight-tested CAD model. It could be a matter of life or death. How is the 3D coordinate data of complex surfaces measured now? It usually is done with the assistance of a very high-end software analysis package that may cost upwards of $250,000. Now that the smaller manufacturing companies are taking on larger, more complex jobs that require inspection of multiple surfaces, they find themselves bottlenecked in providing accurate inspection reports of the manufactured parts or tooling. The cost of this system is out of reach, and a coordinate measuring machine alone is a big investment. However, most of your smaller manufacturers have plunged into the purchase of an inspection device. An inspection device is usually a mandatory requirement when taking on a complex job. Without the assistance of a multiple surface inspection package, analyzing the data taken from a complex shape could take weeks. With the power of today's PCs, an affordable multiple inspection package called VERISURF has finally been developed by a small manufacturer with a vision of the future. For years, inspection of complex surfaces as well as simple 2D shapes has needed improving. VERISURF software is moving forward with this improvement in technology. VERISURF comes with a complete 3D CAD system, which gives the inspectors an advantage that they are not accustomed to. This is the ability to see and analyze the 3D CAD model that is about to be inspected. Not only can you visualize what you are doing, you can also perform tasks that would require a CAD operator to manipulate coordinate systems, or even create vectors that are used to program a DCC coordinate measuring machine. VERISURF requires very little training to operate, unlike most of the high-end packages offered today. You will be up and running in no time using a very simple menu system that your common sense can drive. Watch as the inspector imports a 3D CAD model. It's as easy as putting the disk in the drive, picking the File menu, then Converters, then IGES, and Read. Finally, pick the file name. Now you have the 3D CAD model on the screen. Next, you would import the inspected point data. Both the CAD model and the inspection data are now displayed on the screen. VERISURF is the next choice on the menu. In order to create an inspection report, merely plug in the probe radius and tolerance for this model. Then hit Do It. Now that the part has been analyzed, you can create various types of inspection reports. Let's try one. We'll choose the long format. Notice that the report includes inspection, surface data, delta, and deviation. The bottom of the report shows you the percentages of good points, bad points, and SPC averaging. As you will notice, 2 points exceed tolerance range. With VERISURF, we may be able to save this part using Best Fit. Observe the 2 red points at the lower right-hand side of the model as they come into tolerance. Being that Best Fit utilizes 6 degrees of freedom, It can automatically determine the best alignment for the least amount of error. Verisurf continues to adjust the alignment offset until the errors are reduced to a minimum. In the past, this part may have been considered scrap aluminum, but now, thanks to Verisurf, it's being shipped to the customer on time. Let's take a look at the calculated best fit. Notice the shift is only 2/10,000ths of an inch in the x-axis, minus 7/10,000ths in the y-axis, and minus 16/10,000ths in the z-axis. To calculate this by hand would be very time-consuming and could become a bottleneck. Using the CAD features, we can dynamically drag and rotate the inspection data to the CAD model, putting it as close as possible. With the Best Fit feature, we can align the inspection coordinate system with that of the CAD model. Best Fit will run automatically until it has achieved the best possible results. In some cases, you may be locked to a datum. Verisurf accommodates this restraint with the ability to lock any axis of your choice. If you are in the aircraft industry, you are accustomed to working with aircraft coordinates. Sometimes an engineer uses aircraft coordinates, but when you inspect the part, you are using part coordinates. Verisurf allows the operator to quickly shift from part coordinates to aircraft coordinates, or vice versa, even after inspection has been performed. You are in control. Observe the speed of Verisurf when analyzing 588 surfaces and hundreds of inspection points. The time saved is incredible. Giving a report of a job to a customer or corporate manager can be difficult if all you have to offer is a bunch of numbers. They say a picture's worth 1,000 words. With Verisurf's color plot feature, the results of a manufactured part can be output in 3D color. Each hue and shade of color represents the deviation that is defined in the color plot legend. For example, green represents points in tolerance. Different shades of red points are on the negative side of the tolerance, and shades of blue are on the positive side. These graphical images can be printed out with an inexpensive color printer. With a graphic display like this, any corporate manager or customer can understand the inspection results. To go one step further, Verisurf automatically labels each point with a number that is reflected in the report. As an added bonus, Verisurf will also display and print out the error of each individual point. In the process of using a laser tracking device, a request to read point descriptions or labels from the tracking device is made. Therefore, we not only display the descriptive labels in 3D on the CAD model, but they are also listed on the report. Verisurf dramatically simplifies the programming involved for a CMM to inspect surfaces. Customize the vector report to your CMM's format, whether it be DEMAS, Tutor, Geopack, and so on. After creating all the vector approach point locations, you can run a vector report and output it to a CMM program. Verisurf allows manual CMMs to be used when inspecting complex surfaces. In the past, vector approach was the only method that would eliminate cosine error when picking up a particular point. Since Verisurf uses a more advanced method than most CMM software, you can dust off your old manual CMM and put it to good use with no cosine error. Only a small amount of training is required with Verisurf. The learning curve is quite minimal. An interactive training CD is offered to assist with all of the CAD features like reading and writing files, changing coordinate systems, creating geometry or drawings, and viewing the model from any angle in a shaded colored form. Additional training is offered from your local dealer or direct from the factory. In this sexy, curvy, contoured world of ours, Dozens of different inspection devices are used to ensure that these shapes meet their design specifications. What do these devices all have in common to enhance their accuracy and speed? VERISURF, the icebreaker in quality analysis of complex multiple surfaces.
I had the learning curve down with the VERISURF within 2 or 3 weeks, and I was feeling fairly confident with all the work I was doing on it.
Using VERISURF to inspect complex contours has proven to reduce the time and the cost by 1/4. It also has proven to be easy to use by even my novice personnel.
This is the type of tool we've used in the past to verify complex curves and surfaces. In no way could you get data off a go, no-go tool. With VERISURF, I'm able to check this tool in 1/10 the time with accurate data.
For more information and updates, visit our site